Hello everyone, this is Divasati speaking. We'll talk about machine learning. What is machine learning? Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve. So basically, what machine learning is that normal AI, it's like you have well, what we usually do is we create rules, and according to those rules, we get answers to our questions. So machine learning is kind of opposite. So what machine learning does is that you have data and you have answers too, and the machine learning model will learn the rules from the data and the answers, and it will predict the answers for any new data. Usually that's not the case. Usually we as the programmers, we input some rules, and according to the rules we feed the data, and according to the rules we have some answers. But machine learning is opposite, so we don't have to input the rules. We just need a huge amounts of data and answers. So data in that aspect has become really crucial for machine learning models. So this program here, which you're seeing, is a TensorFlow machine learning program. It uses, it's a linear progression program. So California Housing Train. So this is the CSV file. So we have longitude, latitude, housing, median age, total rooms, total bedrooms, population, household, median income, median house value. So today our median house value will be the label. So label meaning y, or the output. So like an equation, y is equal to mx plus c, where m is the slope and c is the constant. So y is our output. So median underscore house underscore value is our output, and everything else is our input. So we'll be predicting the house value. So in this program, so what we're doing is that our input feature is only one column, which is the total underscore rooms. So this is just for people who want to like start programming. So this is not an actual ML model which will give like really good accuracy or something. We're just using one input feature, and we are trying to predict the house value, which is we'll see what kind of error we get. So for TensorFlow, you need to understand tensor data type, which is okay. So I'll just go through the basics. So input input feature total underscore rooms. This is our x. This is our y target. This is our target. This is our input feature, and we have okay. This is our gradient descent optimizer, and we have a learning rate. We can set our learning rate. So how does a machine learning program works? So what happens is that so we plot a graph between loss. This is loss. Okay, I'm really sorry about that. And weights, or the parameters. Parameters are better. So weight and parameters, or we'll call the parameters theta. So these are the parameters. This is the loss. So we'll plot a graph. So maybe this is a graph like this, a convex curve. So this is a graph between loss and parameters. So for so if our equation is y is equal to mx plus c, and c and m are our parameters. So what we'll do is that we'll calculate the loss against the parameters, and we'll differentiate the loss with respect to the parameters. And if for a particular parameter we have a particular loss, which is mm, which is this which is this which is this point, and our loss is pretty high, and we need to go over here, we need to be at this point. So what we'll do is that we'll calculate the derivative of the loss function with respect to its parameters, and and the negative differential of the loss with respect to its parameter. We'll multiply it with the learning rate, and we'll we'll move the value of the parameters. uh, so the next point maybe will be here, okay, and the loss is less, so it will keep on jumping. So it will calculate the slope, and with its learning rate it will go forward in steps till we reach the lowest point where we have a minimum loss. So we need to reach this point. So what may also happen is that point your parameter is going to go forward, and you might miss the minimum loss, uh, the minimum slope here. So what happens is that the the program will go backwards. It will go back. It will go towards the left of the x-axis, and it will come back towards here, and it will go here. Then it will go here, then here, and it will take smaller steps till we are almost at the minimum point. So at this minimum point, we'll have minimum loss, and we can predict our y using our parameters using our parameters. So that's the gradient descent optimizer. So what this says is that um, it will calculate the slope for the graph loss versus the parameters, and with its learning rate. Learning rate is it's basically the size of the steps which are taken by the program while trying to calculate the minimum loss. If your learning rate is really high, what will happen is that uh, so if you're here, then it will jump here. So it's useless. I mean, it's not useless, but it's not efficient. So you need to have smaller learning rates, not all the time. So like this, maybe this, then it will come back to this. You can also have a bigger learning rate. Um, it all depends on you. It depends on the program. It depends on the problem, like how much your learning rate is. Here, our learning rate is 0.000001. Okay. Okay. What does this line do? This line. So what happens is we the value of the gradient descent optimizer, it's limited. So each step you're taking is has a limitation because of this line of 5.0, so you can't go above 5.0. So this is the linear regression model. Okay, these are all other stuff which is pretty hard, pretty tough. So this is I'm just telling you about this, so you learn the basics. This is a bit hard, so we have this plots our map, sorry, a graph. Um, okay, this line trains our model. This line it computes the prediction, computes loss. We have all of this. We train the model here. Okay, so here, okay. So in a machine learning program, the most important thing is loss, which loss function you're using. Okay, the optimizer like the learning rate and all is fine. But your loss is also really important. Where's loss function you're using? Here we are using RMSE, root mean square value, root mean square error, as our loss function. So different problems require different loss functions. So it totally depends on the problem. So here we are using RMSE. So I'll just run the program. Okay, so uh, I ran this okay, the program is running. So this is our graph. This is our points. So total underscore rooms and median house underscore value. And it starts the training. Okay, so this is the RMSE value, 225.63, and it's pretty bad. Of course, we are only using only one input feature, which is total underscore rooms. In reality, it depends on a lot of other features, so we don't have a really good uh, accuracy. So I'll just stop this program. So this is like the basics of machine learning. This is how like a linear regression program works, a TensorFlow program works. So we'll talk about Keras. This is the most simple program, simple machine learning model, like program in Keras. So we'll be talking about MNIST dataset. So if I go to this program, okay, here, okay, not in this, okay, this one. So from keras.datasets, we are importing MNIST dataset. MNIST dataset is a collection of images of handwritten digits from 0 to 9. So there are, I don't think so, 60,000, I don't know. There are numerous images of digits, handwritten digits. So what this program will do is recognize each digit. So in our handwriting, it will recognize each digit of the image. So some people write 7 differently, some people write 2 differently, some people write 1 differently, and the program, this program will recognize each digit as as it's shown in the MNIST dataset. So I'll just run this. Okay, so this is one image of the MNIST dataset. So this is 7, of course, we know what it is, but not everybody knows. So not the computer knows, and this is 2. So we have like 60,000, I guess, I don't know, 60,000 images. Okay, before we run the actual program, so we are using Keras module. It's a, okay, so we are using neural networks. We are creating neural networks to solve this problem. First line, we have models.sequential. This is our test underscore images. It's from here, test underscore images. First, this this part of the program helps us display the MS, like the image. It helps us display the image. So it stores the data set is stored as an NumPy array. So each it's stored as an NumPy array. Okay. So we are adding. This is our first layer. We have an activation function which is called reloop. Yes. This is a reload activation function. So it's like this. So we have a numerous activation functions. This is the rectifier, rectified linear activation function. We have sigmoid. Whichever activation function we are taking, it should be differentiable for back propagation. So this is our activation function, and every our activation function needs to be non-linear. So if it's a linear activation function, it's not much useful because we are trying to we are the model is trying to learn non-linear functions. So we need a non-linear activation function. This first layer is the input layer. It takes the input 28 into 28 comma this, okay, and the second layer is the output layer, softmax. Softmax is the activation function. So for every category, so we are dividing the digits into categories, 10 categories, 0 to 9. So for every category based, so we are not, this is like we are finding out which category the digit belongs to. Is it 0, 1, 2, 3 to 9. So for every category based problem, the last layer should be softmax, and it needs to be 10. Okay, so 10 neurons because there are 10 digits. So this line compiles the model. We are using RMS prop. It's a optimizer, just like a gradient descent optimizer. This is a loss function, categorical underscore cross entropy. This function is mainly used for category based problems for digits. So we are dividing it into like 10 categories. So we are using this function. Our metrics will be accuracy. We can have different kinds of metrics, different kinds of optimizer. We can use Adam as well. Like there are many optimizers, many loss functions, many activation functions. So this line here converts the train underscore labels into categorical type data type. You need not know about that. So we are, this line trains the model. So train underscore images is our input features. This is our output. These are our answers, labels y. This is our x. This is the number of times the program will go through the data set, epochs. This is our batch underscore size for each run through the program. The batch size is 128. There's nothing much. This will evaluate our test underscore images and test underscore labels. We'll print the test accuracy too. Okay, this is really simple. I mean, yeah, there's much you need to learn about. That's fine. Okay, so we'll run this. So I was talking about it's stored as numpy arrays. So this, think, think, where is it? Where is it? Yes, test underscore labels. Yeah, it's stored as numpy. It's a numpy array. It's an array stored as an array. So this is our epoch number 1. loss under, yeah, our accuracy is increasing slowly and our loss is decreasing. You can increase the number of epochs, number of times the program, like it goes through the data. But the problem is that when you're taking huge amounts of, you can also overfit the data. So what happens in overfitting is that the the model will overly overfit the data. So you need to under the model needs to understand the generalized patterns of the data. It does not need to learn specialized patterns. These more specific the patterns the model learns. So when you're trying to use the model, trying to predict your output on new data, it becomes the accuracy will decrease because the model is has not it's not generalized. It's more specific to a particular pattern. So you should be careful that you're not overfitting the data. So every time, even if you're this is our accuracy on our test images and labels, which is 98.16, which is fine. This is our accuracy 98.87. Accuracy does not, our accuracy or any kind of metric will not tell you exactly that the model will give you like is the model accuracy on the on new data sets. So it's some you cannot judge the machine learning model with accuracy. Of course you can, but you always need to test it on new data. And when you're testing your machine learning model, always test it on new data, on different validation data set. Or if you don't have even if you don't have lots of data, there are ways. Okay, so okay, so here this is another example of a Keras model. In here, what we have done is that we have divided the data set into five, I guess. Okay, yeah, four. So into four different uh, data sets, and what we are doing is that we are uh, training on three of those data sets, and we're using one of those data sets as a validation data set. So we are doing it four times and four different, like we are one, maybe the first data set is our validation data set uh, is 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 uh, is the data set which we are not using to train the data. We are using the validation data set to validate the model. So whenever you want to validate your model, never use the data set which have used to train the model. So there are different ways. So here, because so what I'm doing is this is a different type of Keras model. So when you have like less amount of data, this is what you do. Okay, categorical cross entropy. Okay, so we are using neural networks to learn non-linear functions. So I mean non-linear type of patterns. So the previous program, the huge one, this one, which is California Housing Train. This is using linear regression. So what's basically happening is that in the graph that we saw, okay, so this is our graph. So what happens in linear regression is that we have one single line which will go through the data like this. Like it will go through the data points like this for minimum loss. So right, right now you can see that a single line is okay. So what happens if your data set is like the points are scattered and a single line is not the option, like it will not give you like better accuracy, and you if a curved line is better for using curved lines if your data set is so we use neural networks to learn nonlinear functions. So this is it. This is our this is this is MNIST data set. How we okay. Matplotlib is used to plot graphs. NumPy is for NumPy arrays. Keras is our neural network module. We are importing an MNIST dataset. So that's all. Thank you. Is that all? I guess. Yeah, that's everything.